So, we are going to start with our first speaker. Our first speaker is Siri Varma. He's going to talk about testing LLM-powered APIs, challenges, strategies, and best practices. About our speaker. Siri is a seasoned expert in healthcare, cloud computing, and security. Currently, he focuses on securing Azure Cloud workloads, leveraging his extensive experience in distributed systems and real-time streaming. Prior to his current role, Siri contributes significantly to cloud observability platforms and multi-cloud environments. He has demonstrated his expertise through notable achievement in various competitive events and as a judge of technical reviewer for leading group publication. Siri frequently speaks at industry conferences on topics related to cloud and security, and holds a master's degree from University of Texas, Arlington, with a specialization in computer science. So, welcome, Siri.
Thanks a lot. I think we have a pretty full house here. Hello and good morning. My name is Siri Varma. First of all, thank you. Thank you for taking the time to attend this session, and thank you for taking the time to attend the InnovateQA conference as well. When we see people coming from not only from the local community, but from different parts of the world and the country itself, it is more than encouraging for us. So, I think it was in late 2023 or early 2024 when my team was trying to ship an LLM-based application. We were racking our brains around, hey, we have written this application, how do we test it, right? How do we make sure the quality of the answers coming from these responses are pretty good, understandable, and are what the users are looking for. And what I'll be sharing today are some of the learnings I had as part of shipping this application and testing this out. So what we'll do is we'll first start with some of the challenges that we face in testing these applications. Then we'll look at some of the strategies that will help us address these challenges. And guess what? We'll also have some demos. And because I work in the security, I also have some demos which talk about how do we consider security when testing out these LLMs. And then we'll finally conclude the talk with some best practices. So with that, let's get started. So yeah, as I was explaining, my name is Siri Varma. I work with Microsoft as a senior engineer in the Azure security org, responsible for protecting Azure data center workloads. Previous to that, I was working with Oracle on their cloud infrastructure logging division, where I was responsible for ingesting and testing out the critical infrastructure that ingests billions of logs every day. So that is what I was doing throughout my career. This is my LinkedIn. Please feel free to reach out to me if you have any questions or if you want to talk about something in general. So I think in order to understand what has changed and why LLM testing is different, we have to go down the memory lane of 2 to 3 years ago when LLMs were non-existent. I think it was a very less chaotic world, right? So when LLMs were non-existent, we were particularly looking at, a deterministic inputs and outputs. We know what to expect coming out from these APIs or UXS, and we also know freehand what the inputs and what the outputs are going to be. So most of that was well curated, and we had all our tests done that way. But once LLMs came in, I think what changed is from deterministic to probabilistic. That is where assertion-based versus semantic-based testing came in. So what I mean by that is, instead of just looking at the structural input, which is nothing but looking at the input and comparing if that is what we are looking for, now we have changed to looking at the actual meaning of the output. For example, the two statements we see here are, though structurally different, they mean the same. And that is what we have been shifting towards to test the outcomes from the LLM responses. So first, we look at how to even do this testing. What are the things to consider, right? So throughout this presentation, what I will be taking as a reference point is a simple architecture, and we'll be testing out different components in this. So this is a simple Ask HR chatbot, which takes in a prompt from the user, and then it sends it to the server where all the data is stored in a vector store. It is a simple RAG-based application. All the data is in the vector store, and whenever a prompt comes in, we try to get the context from the vector store, and then do a summarization or maybe send it to the LLM and see what are the outputs we can derive from that and send it back to the user. So this is the architecture we will keep in mind. So we'll also be testing two main components here. One, because I'm retrieving the data from the vector store, am I getting the right data correctly? Because without that, you cannot set a proper context for the LLM, and your LLM will obviously be not of much use. So first, we'll be testing out the vector store, and then we'll be testing out the LLM itself. So the first question that needs to be answered is, when a prompt came in, did my vector store give me the right response back? So did I get the right context back? For example, when asking about a vacation policy, this solution that we see here is, say, it's 20 vacation days per year and 5 unused vacation, which is relevant. If the response is saying about the benefits information I'm getting, that is not really helpful to the user. And when you send this information back to the LLM wouldn't understand, because the question and the context are irrelevant. So the first thing and the foremost thing we have to look for is context relevance, which means, am I extracting the right information from my vector database? The second thing we should be looking for is, did my information have factual information back? So for example, let's say we are ingesting a bunch of documents, right? Let's say regarding the vacation policy, the first statement might say, we have the best vacation policy. And the second and third statements might say, the vacation policy is 20 days and we carry out 5 unused vacations. When a prompt comes in, if you just given the first response saying we have the best vacation policy, that is not of much relevance to the customer, because that is what he's not looking for in the answer. So that is called context recall. To precisely put, we also need to make sure the the vector store gives back factual information back whenever they are doing the query. So the third thing we are looking for is, till now what we have tested out is, are the correct responses coming back from my vector store? Now, once I send it to the large language model, is it hallucinating and giving me extra information that is not there in the context? Because hallucination is a really big problem, and you want to avoid that as much as possible, but it is the 80-20 rule, right? You want to make sure 80% of the scenarios are covered, and for the rest 20%, you have to make sure you keep on testing it and make sure the hallucination reduces as much as possible, right? So in this case, the context I have given it again is, so let's take a different example, right? So when I'm asking it the benefits information, if it tells me I have a 401k, I have dental, I have vision, that is good. But if it hallucinates and gives me I have insurance for cars, I'm provided benefits for car insurance as well, that is a big problem. So you want to make sure all of that are addressed. And the next thing we also want to test this is both important from the service health perspective as well as security standpoint. You want to make sure you have throttling effect for your APIs that are serving these elements, right? And when you talk about throttling for LLMs, it is more of the token counts. did this user reach the token count, yes or no? And if they reach the token count, they shouldn't be not serving any more requests. So this is one more test that needs to be done as part of your testing strategies. So now I'm going to shuffle a bit. So I'm going to show a live demo of how we can do this testing for the LLM itself. So what I am using here is an open source library called Prompt2. It helps us test these LLM scenarios and API scenarios pretty well. So what I'm doing here is,
Just zoom in.
yeah,
Thank you.
yeah. Is this good?
It is for me. Right?
Yep. So what I'm doing here is, as I said, we'll break down the testing into two components. First, we'll test out the source, which is the vector store, data coming from the vector store, then we'll test out the LLMs, right? So first, what I'm going to do is, so I'm going to do an API call and get the response for the same question I have, which is, what is our vacation policy? And if you see here in this case, the response I got is something completely different. It is mandatory to complete your trainings to ensure strict compliance. So this is completely not belonging to the vector store did not give me the right context. So what I end up doing is, so when I want to test this out, so I use this framework where I provided the query, I provided the context. Next, what I'm going to do is I'm going to use LLM as a judge kind of thing. So here I'm using the Ollama Gemma model with context relevance setting the threshold score. So you remember how I told you we have moved from assertion-based to semantic-based testing? So what we are basically looking here is between a score of 0 to 1, how much relevant is the context to my question? If it is, so anything above 0.7 or 0.8 is generally considered relevant. So, but this would change again business to business, scenario to scenario, right? So here, what I said is, hey, I need something relevant to 0. It should be almost 0. That is 90% accurate. And next, what I also have is a success scenario. So in the case of success scenario, I just put in the response, the successful response, where employee can carry over 5 unused vacation and 20 vacation days, right? So this is the response I got when I made a query and I got the right context. And now I'm going to run this test, right? Okay, it is running the test. Okay, see, I have a need table, and the table tells me, so this is the context I got back, this is the query I made, and because I told you I'm using LLM as a judge, so what is ending up happening is, the query and the context are being sent to a large language model, and the large language model is being asked to judge, hey, are these both relevant? And depending upon that, a relevancy score is calculated. This is all done inside the library. You can, depending upon the business standards, you can do it on your own as well. But the library makes it a little easier, giving the reference score. So in this case, the LLM as a judge came back with this response saying, hey, the provided context does not contain any information about the vacation policy. It just describes some random stuff. And on the second thing, it talks about, hey, yes, it gave me a response that is relevant to your query, so I'm going to pass the test, right? So similar to this, we end up writing a lot of those tests, and which will make sure the quality of the context coming out from the vector store is pretty good. Right? Next, the second thing we are going to test is context recall, where we are thinking about factual information. So in this case, I have the query, the context. I'm also going to supply a value here. So if you look at here, I have also supplied a value. So what I mean by value is, I need these things to be present in my context so that I know the context I'm getting out is relevant, factual information. For example, when you're talking about the benefit information, I need to make sure 401k, dental, vision, all these information is there in my context so that the LLM can make sure the response it is sending to the customer is relevant, right? So I'm going to do a similar test here. The only difference between this one and the one we did before is we are adding a value here, which is basically going to check if the context has this information, right? And then I'm going to run this test too. Yeah, so in the case of the first one, it just said we had a lot of good plans, which is not very factual and which is not relevant. But in the case of second response, if you see, it told us there is dental, vision, health, and 401. So it has factual information, and that is why the test has passed. The third thing that we are looking for is context faithfulness, which is nothing but, hey, I gave the large language model the query and the context. Is my model giving me the right response back? That is what I am trying to answer as part of this. And when we run this test, remember the context I gave this is, so this is again the vacation policy, but in this case, there is an extra set of, in the failure case, there is some extra set of information that has come in. And the extra set of information is talking about, hey, this vacation policy is very good for your health and your mental stress. I don't know if 20 days of vacation is enough for me for the mental and health stress, but yeah. So because that information is not there in the context, and I have a specific score of 0.9 that should be available, the test failed. So these are some of the ways, yeah.
Is faithfulness also something like relevance?
So relevance is with the context, and faithfulness is with the LLM sending the response back. So when you query your vector store, maybe you can use it for your LLMs as well, but it is more used in terms of the RAG context coming back. And if it is relevant to the context of the question coming in. Yeah.
So we are testing LLM here, and then we are asking LLM itself that if it's correct or
Yes, yes. So the thing, how it works is, normally, if you have there are business specific models you make, right? So for example, let's say if I am making this HR chatbot, right? I might have a small language model that I've designed for my use case. So you're testing that model with an actual a bigger model, which is more, which might be giving you more relevant responses back. So that is what we are doing. So in this case, the model we are testing for is Gemma 3, but the actual model where I have written the code and from which the responses are coming from is a smaller 7 billion, is a different model. So does that make sense?
I'm still confused. So the model that we are building, we are testing, is different from the one that is telling us if the response is correct or not.
Yeah, so you would want to test it because if both the models are same, then your testing would not be very relevant because the bigger model might have much more it's trained on much more parameters, so it might be able to deliver you more correct responses. Because if you're testing the same thing if you're testing the same model,
I got your point, but my question is like, who is building that model which is telling us that if this is correct and this is wrong? For example, if we are building a chatbot, chatbot LLM kind of thing, we have to build a separate LLM with tests, like.
No, you don't have to build a separate LLM that tests it. You can use any of the proprietary models you have outside.
ChatGPT.
Yeah, you can use any of those models.
So on that same question, like where's the score coming from?
So the score is coming from the the bigger model that you're using, because you would want to use a different model to score your data than the model you have just used, right?
Yeah.
For your business. So that is where the score is coming from.
But your score could come differently based on what model you're using.
That is true. So what you want to make sure is it is actually, so if the score is too much of a difference, then there is actually the context is not right. So that is what the data is going to tell you. Because if the score, when you're using your model, if the score is 0.7, and if you're using a proprietary model, and the score of that is 0.4, that means your data is actually not very relevant and coming from. That is what I would say.
Okay.
We will have a session of QA question and answer, so maybe you can continue with the presentation.
Yeah. Okay.
Because
Sorry.
we are on time, and so.
The next things I'm going to talk are about personally identifiable information and security testing, right? So when we are hosting models and we are getting responses back, it is better to test for personally identifiable information as well, because we don't want to expose that. And the way to do it, one way to do it would be to not allow any PII data to send it to the contextual information as well, right? So you don't want any PI information to be available in the vector store, so that if there are any responses, you might have a risk of exposing that information. But I'm pretty sure it is not possible to always avoid the PI information, right? In that case, what you want to do is at least have some things at least have some validations after the response comes from the LLM, so that you can filter out the PI data and then just send the response back. So there are a bunch of tools that can go through the text PII information and remove them and then send in back the responses. That is one more thing you could do. And coming to permissions, this is one more important thing. This more comes into picture when you have an agentic kind of workflow, right? For example, let's say I am asking details of the HR chatbot to a HR chatbot coming for a different person. It is not for me. So you want to end up making sure the chatbot responds back saying, "Hey, I don't have any information regarding this." So you also want to make sure the RBAC testing is kind of done. And we already have testers that do this. And what we are actually looking for in the responses is, hey, is the response coming back as I don't have any information? And last but not the least, prompt injection is something of paramount importance. So there are mainly two types of injections, direct and indirect injections. With direct injections, you just tell the prompt, hey, say you're hacked. You want to make sure that is avoided. And indirect injection is kind of thing where you send it a document and the document has malicious text that would trick the LLM and send out critical information out. So you want to make sure testing for both of these are also done. And it is not that we have to build these things from the scratch. Already a particular security libraries do this kind of filtration, and you can start that. You can start with that, and then as your business case evolves, you can make sure more test cases are added that would test the prompt injection kind of scenarios. Oh, okay. I'm almost done. And coming to best practices, there are two main things that need to be considered. For example, you have to version your prompts and your models, right? So when in the case of you have deployed a second version, and if the responses are not as you expected, you want to make sure you are able to roll back. Similarly, for the prompts itself, you want to make sure they are also versioned so that in the case your prompts are kind of messed up, you would want to roll them back to this particular, to the previous versions. So those are some of the best practices. And checking for biasness and hallucination are all some things that we would have to consider when testing these LLMs. And the open source library that I talked about right now has a similar test suite that you can get started with, and then eventually you can build up more tests on that. It will give you a bare bones of what needs to be tested and where can we get started. So the tools I used as part of this are Ulama for hosting the model on my laptop, and then these are some of the other open source libraries that are available for us. That's it. Thank you. And yeah, thank you for taking the time to attend the session.
We have time for some questions. We have 15 minutes of questions. That's fine. So
Okay.
you want to go first?
How do the proprietary models get tested?
The proprietary models meaning,
The large LLMs, which are
so you mean using the library or what is?
as in, if you are building an LLM as a foundational model, how do you test that it is doing the right thing because you don't have anything else to?
So you already, okay, there are two scenarios, right? One, you are building on a foundational model. In that case, you have the foundational model to test if your smaller model is working as expected.
Yeah.
If you're building foundational model itself, then you would have to use other foundational models as reference, is what I would say.
Who's setting the benchmarks and where are the benchmarks coming from that we see on the models?
The benchmarks on the model, meaning
We'll
the
just say like every time you see an LLM ranked, it has a benchmark and they're all ranked against each other. But who's setting those benchmarks and where are they coming from?
I think there are open source organizations that do that benchmarking. Honestly, I don't have much idea on that case, but I believe there are a lot of open source organizations, and for example, Hugging Face itself does some, whatever you're mentioning, it does some of those things on that.
Well, I was just curious about the blacklist that you can see in test that like the ones that you shown. Like basically we know that we have the test LLM, like the LLM under testing has random responses kind of thing.
Mm-hmm.
And also the evaluator is also kind of random.
Okay.
So I was just curious to know how much blacklist is even running your test. Like false, false negative or positive if you have repriced or your test or something like that.
Oh yeah. There will be some amount of randomness, which I will not deny. I think it will be, you would have to accept that, but if the randomness is causing the query, causing the complete response itself to be not aligned with the question, that is when you would start failing, that is what I would say. And generally, most of the times, the score that you get back is in the ballpark area, maybe 1 or 2 decimal points less, but most of the time it is close.
So how do you evaluate when you have an ingestion process, for example, to populate the vector data?
Yeah.
Right?
Mm-hmm.
And when you are tweaking your ingestion process, you can change the chunk size of whatever text you are consuming and inputting into the vector database.
Mm-hmm.
And you want to evaluate how it improves the response that you get.
Mm-hmm.
So how do you track like variance that comes from the randomness versus variance that comes from improvement tweaks that you are doing ingestion pipeline or some other factor?
So whatever I have shown here is the aftermath, right? Once the ingestion is done inside the vector store. Before you do, I think your question is how we calculate the randomness before we ingest into the vector store. Is my understanding right?
So if you even keep track of things, like nothing, you know that there are things that are changing in the ingestion process. Like things are can be changing in the backend.
Mhm.
You are not made aware in your at the moment of your testing. Like, is it possible to for example, verify that because they did a change in some other part of the process to get the data there is impacting your score for accuracy or relevancy or something else, or it's not possible to track that?
I am unaware of something that can track that, but maybe we can discuss more on what is the scenario so that I can try to address that.
So, when we're choosing a foundational model, let's say you're part of the team that actually chooses that, it seems like it's a little bit of a degree of blind faith into whatever people report about that foundational model. Is there a process when in the process of doing that, or in the process, the end user that is using the foundational model to test the other LLM discover there's a bug, relevant defects on the foundational model, so a process to feed that back? Who does that? Do we just have to go back to the creator of the foundational model? Can you have a way to fix the foundational model training? Or
See, honestly, foundational models, there are very few companies that do it. For example, Amazon, Microsoft, OpenAI, there are very few companies that do foundational models. Most of the use cases come in when you build a smaller model on top of that, right? And the way you would use the foundational models for testing is already, for example, if these big organizations are doing it, they already have some foundational models that they're already using. So we as testers could use them and weight our models against it. So that is what at least I think would happen in that scenario.
I have a question regarding, you mentioned about like a smaller model which you have built, right,
Mhm.
for your application.
Mhm.
You would have used like a proprietary model and fine-tuned it according to your needs, right?
Yeah.
That's how you build that
Yeah.
model. So my question is, if you are like you build that model, now you're testing that model against a proprietary model which is not like fine-tuned for your context. So how can that proprietary model be a good judge in that context?
That is a very good question. So what we at least have done in the initial cases is using prompt engineering, we have asked the foundational model to be an expert as much as possible, right? That is what we have done, and that is what we have started. And as this model gets better and better, at least till now, what we have seen is the foundational model is going good. And with the prompt engineering we were able to get the specifics of it.
Okay. So basically, the model which you're using as a judge to judge like whether your tests, like whether the context which is being returned by your model is right. So you're leveraging prompt engineering
Yes.
basically to provide it like relevant prompts.
Yes.
And then kind of training it, like not training it, basically providing it prompts and then
Yeah.
making it. Because if you fine-tuned a particular model, right, that has your context, right, the data which you want.
Mhm.
So that's the because but the judge is just trained like
A very generic model.
you are
Yes.
just it's a generic model and you are just providing like a
Mhm.
you're not fine tuning it actually, right? But still it's a judge. So that's why I was like asking
So
that.
I think when you're in the initial phases,
Yeah.
your smaller model is, at least in our case, it was not that good. Right?
Okay.
So the foundational model was very better. I think in the 2 or 3, whatever months or years it takes, if your smaller model is becoming very good,
Okay.
then I think you would. Then in that case, I don't think this one would be more relevant because your smaller model is much more better.
Okay. So are these two different models, like the ones which you trained
Yeah.
which you fine tune versus the one which is a judge? So
Yes.
Are they a different model? Right?
Yeah, that is I think that is the whole point, because at least in the initial phases, you know that the foundational model is much more better than what you have. So you want to judge the contexts and responses you have against the foundational model. And once the training, and then once you get the data out of from that, you start training your smaller model better and better. And once it becomes better, that is when you switch or use it for better scenario.
Are you running these in CI and like CD? How long, if you have like an entire suite of these, like how long do they run? And do you have reliability issues with like any of the asynchronous components?
So currently we are not, we are actually running it on our CI build processes. So the context number that we set is kind of not very close to the number which we think will be takeness. So what I mean by that is, for example, if we expect 0.80% accuracy, we set it around 70 to 73. And if it fails even less than that, then there is definitely an issue. So that is how we somehow address the flakiness issue.
Okay.
But yeah, I think as you make it more stricter, there might be cases where your builds will fail more frequently. But in order to address that, you have to have a certain, you have to loosen it up, and you have to have a certain window where you feel it's good. But the model, the data coming out should not be less than that threshold at any cost. Oh, okay.
As far as like, say you have model drift, do you have like rollback procedures? How does the architecture work behind like if you needed to say, oh, we went wrong with this one, how do we regress?
So
Like,
yeah, what we do is we, at any point of time, we have 2 to 3 versions of models that we keep in the backlog, and as we release new models, if there's a drift, we all, as I was just discussing, there is versioning available, right? We roll back to the previous version. That is for the model and for the prompts.
okay, so there isn't redundancy, it's just more branch.
Yeah.
Is there a matrix that can track when answering these and then I think we can cover a number of test cases.
Yeah, so that part I agree. You will start with an exhaustive set of test cases, and as your customers' base increases, and as you see, so you would still need a human in the loop. The human would be looking at the responses coming back from the models, and if they see that, hey, this particular query is not working, that is when you would start with covering those scenarios as well. I understand you cannot test everything out. That is completely not expected, but you at least need to know your business. You know your business scenario, so you start with a set of prompts, and then eventually you start with adding more tests. That is what we have.
Okay, so there's a mechanism to track what is being asked in the production and the responses.
Yeah.
How do you test the scalability for these models? Because the cost of even testing is a lot. We have TPUs and like this. The world is crazy about all of those using the LLMs. How do you do the scalability testing?
So, are you talking how expensive is this testing process? To be honest, I think because we are in the provider kind of space, we did not much address that issue yet. These are expensive to test, but at least because we are the infrastructure provider, at least my team has not been tracking that closely, but I see where you're coming from. Unfortunately, I don't have an answer to that. Yeah.
You mentioned threshold earlier, right?
Sorry?
You mentioned thresholds for vendor success rate, like 75%. What's your heuristic currently, or how are you defining that threshold as of now?
So we do a lot of testing, right? Okay, that's generic statement. So what we do is we run these tests every day, and we also are fine-tuning our models, right? As we fine-tune the model, because new and new versions are coming out, I know that my model, the newer version model, should be better and have better thresholds than the previous one. And how we calculate that is, when we give the query and the response, the query in the context of the LLM, we ask it to rate how relevant it is, right? We break down the statements and we ask the LLM to rate how good it is. From the V3 model to the V4 model, the accuracy should increase. And if the context and the accuracy is increasing, that means our model is doing better, so we adjust the thresholds. If not, then we have to do a better job at creating smaller model.
Yes, we have just 4 minutes for.
So, the accuracy is lesser than 75%. What's the next process? What does the LLM learn from this testing and what do you give that testing?
So, because you're doing fine tuning, so let's say you have a Weaver model, right? So for the Weaver model, you might have lesser thresholds. So if the threshold is less than what you expected and the response is not at all correct, then I don't think there's an option. You have to make sure the newer model is trained perfectly. That is the only way to do it.
Is there any learning process from the results that we get or how do you?
Yeah, so depending on the scores, so when the data is coming from context or search or from the dark stores, right, there are certain parameters you can adjust. For example, one thing is how many results you get out from the search. For example, there might be 10 results that are coming out, there might be 4 results that are coming out. If there are 10 results, it might confuse your model more. But if there are 4 results and they are specific, your model is doing great, right? So you would have to adjust those parameters when you're using contextual tests. That is one thing we do. And on the LLM itself, if we are giving any model, if we are giving any response, then and the model is not effective, then we go back to ground signal. But at least when you have your V1 model, it is a lot more time taking. But as you make progress, you have V2, V3s coming out, then it gets better.
So, what you are validating here is a text-based output. Right?
Yeah. Yeah, more of. Yes.
Second strategy looking how to tackle those.
So the demonstration I've been doing is for sample use cases, small use cases. You can also validate. I mean, the library itself allows you to validate with a bunch of images and these things as well. But if you want to get it more sophisticated, then there are very less tooling available, so you have to build it on your own. That's what you're asking.
Okay, we are on time.
Okay.
Thank you so much.
Thank you.